Welcome back, guys. This is a very important problem that can cover the conservation of mechanical energy as well as the linear impulse momentum principle. So what do we have here? In fact, we have a pendulum that is consisting of this 4 kilograms wooden block, all right? And it was at rest when theta is equal to 0. So this is my body. It was at rest when there is no bullet and when theta was equal to 0. Now, when 2 grams, right? So make sure you convert this to kilograms by dividing it to 1000. So when a 2 grams bullet strikes and becomes embedded in it, so this 2 grams bullet is striking this pendulum, but after collision it becomes embedded in it, which means it will have the same velocity as this system, right, as this pendulum. It is observed that the block swings upward. So when this 2 grams bullet strikes this pendulum is moving upward, alright? So it's observed that this block swings upward to a maximum angle. What does maximum angle means? Maximum angles means the velocity will be equal to 0, right? And theta is equal to 6 degrees. So whenever this theta is going from 0 to 6 degrees, the velocity will be 0. I need to estimate the initial speed of the bullet, right? So I need to estimate mv1 of this bullet. So let's take this bullet as my system, right? What are the forces exerted on this bullet? In fact, just before and just after collision, if I apply the linear impulse momentum, there is this I will be equal, the linear impulse will be equal to 0. So I'm gonna say that for this bullet, the sum of mv1, and I'm gonna show you why I'm using the sum of mv1, is equal to the sum of m at state 2. Alright? Now, the sum of mv1 just before collision is only what? For this bullet. Why? Because this block was at rest, alright? So m bullet times v of the bullet, which I need to find, plus 0, and this is for the pendulum or for the block, is equal to mb plus the mass of this block times v. Alright, let's call this v2. Now I need to find this v1, but I don't know this v2 also, alright? So I need to find also this v2. I know mv, it's 2 over 1000. I know mb plus m because I know that this is 4 and this is 2 over 1000. So I need only to find v2. If I know v2, I can find v1. How to know v2? I'm gonna take this block as my free body diagram, and I'm gonna apply the conservation of mechanical energy because in fact there is no frictional force between theta is equal to 0 and theta is equal to 6. Why? Because in fact if I do this, I know that t at theta is equal to 6 will be equal to 0. So the kinetic energy at theta is equal to 6 is equal to 0 because in fact it's the maximum angle. Alright? So I know that T1 plus, I'm not gonna call it T1, I'm gonna call it T2 because it is at this velocity 2, alright? So T2 plus V2, I mean by this V2, the potential energy and not the velocity, alright, is equal to the kinetic energy 3, and I mean by 3 when theta is equal to 6 plus V3. Right. So I know that this kinetic energy is equal to 0 because it is at the maximum angle. Alright, and I'm gonna specify my datum as this one so that I am sure that so this is my datum. No, I'm not gonna apply this as my datum. I'm going to apply, this is the center of gravity, this is my datum, so that I am sure that this block here, the potential energy of this block here is equal to 0. Okay, so this is equal to 0. So I took the datum as at the center of gravity of this block when theta is equal to 0, so that V2 will be equal to 0. And then I have only T2, which is half m V2 squared. And then I only have the potential energy at 3, which is when theta is equal to 6. Now, when theta is equal to 6, this is the center of gravity. And what is this distance about? What is this distance in fact? Right? So what is this distance? In fact, this distance should be the same as this one. Alright? Because in fact, the block swings upward. Alright? So if this upper level of this block is moving upward with this distance d, then the center of gravity will also move upward with the same distance d. Now what is this d? If I take this d here, it is in fact this 1.25 minus the projection of this 1.25 on this side, alright? So if I do the projection of 1.25, which is 1.25 cosine 6, and I subtract this distance from the whole distance, which is 1.25, I'm going to have this distance d. Right? So d will be equal to 1.25 minus 1.25 cosine 6, or 1.25, 1 minus cosine 6. Alright? So half mv2 squared is equal to m g, and it's positive in fact because it's moving upward, because in fact the height is, or the position of this pendulum here, or of this wooden block, is on the upside of this datum, so it's mg. Alright, I'm not gonna say it's m times g. In fact, let's call this ms. V2 squared is equal to ms g times h, and h is 1.25, 1 minus cosine 60. Of course, what is ms? It's this one. It's mb plus m. Alright, so I know all of these terms, so I can find V2 whenever I know V2. I can plug it here, and then I can find V1. You can do it by yourself. And then V1, which is the velocity of the bullet before collision, it's the initial velocity is 733 meters per second. Thank you.